Now time to draw out the hexagons. I've used dark marker to show you the outline of the hexagon, but when you draw up your plywood, only use a pencil, because the danger with the marker lines is that even if you plan to paint your telescope later on, it could end up with the marker lines bleeding through your paintwork. So stick to using a pencil, it's easier to get off later on. Start by drawing a line 500 millimeters from the edge into the board. That's how wide your hexagon is going to be. It's 500 millimeters from one face to the other. Then draw a line 250 millimeters in, which is the halfway line, and have the two lines going up the board. Now for a bit of mathematics. The internal angle between two adjacent sides of a hexagon is 120 degrees. This edge of the board here is 180 degrees, and so you take 120 away from 80, which leaves you 60. You then divide that by half to get the angle of the two sides, which is 30 degrees. You line your set square up on the edge of the board so that you can see that it's parallel on both sides there and there, and then you draw your line correspondingly at 30 degrees there. You turn the set square over the other way and you do the same for the other side. Again, line up the set square on the board. You then measure how long the face of the hexagon is going to be, and it works out at 288 millimeters in my calculation here. So you mark up 288 millimeters from that corner to there. You do the same on the side here, 288 millimeters, and make a little mark. Then you take your set square so that it's up to the centre line. You make sure that the edge of the set square is parallel on this side of the board, and bring it in gently until it corresponds with the 288 millimeter mark there. When you're satisfied that it's slightly in to allow for the pencil mark, you then draw your line to the centre line there. Repeat the operation for the other side after turning the set square over. Get the set square parallel with this line on the board here. Once it's parallel, you mark up that line there to the centre. Now, you want to separate out the two hexagons, so using your set square, put it up to the line here and mark it so that at the point where the one hexagon is going to meet the other, you've got about 1.5 millimeters or 2 millimeters of overlap between the two hexagons, so that when you saw through from one to the other, you can just cut straight across the board. With the cradle side panels, you want to cut out the circle before you cut across the line of the top of the cradle side. So it's 38 across, so you have your centre at 19 centimetres. You set your compass for 115 millimeters, which is half of the diameter of 230, which is the same as the circles that you use to cut out the centres of the baffles. Carefully line your tip up on the centre mark. Draw your circle out. Make it quite bold. It makes it much easier when you're cutting later on. So mark up your two circles on the two side panels of the cradle, and then cut out the semicircles, which you can then use for a bearing if you don't want to use the ones in the centre of the baffle that you took out earlier. When cutting out the cradle sides, there comes a point where the neck of the saw may come into contact with the side of the board. That is, if the one that you've bought hasn't got the same reach as this blade to the back here. If that's the case and you find you can't get to the very middle because the blade's starting to distort, don't panic. Take the coping saw out of the piece, and then using a saw you cut a section away, cut triangles out, and that way you can get your saw into, you can create a hole effectively for the saw to get into so that you can carry on with your line. I would recommend that you use both of the baffle centres, because before you make these into bearings you actually have to remove 3mm of material from around the edge. That's so that when the bearing is sitting in the holder, at the moment you've only got the thickness of the saw blade separating the two. You actually need to spread that distance a little wider because you've got the two Teflon pads that these semicircles have to ride on. Centre the compass on the hole you originally used. Set the compass to 3mm inside from the edge and draw your circles around the outside like so. So having drawn your two circles out, take your coping saw and cut just on the edge of the pencil line, but this time outwardly. So you're just removing a very thin fillet of wood away from the outside edge. Having done that, you then mark up your two circles in the centre, making a thick pencil line either side of the pivoting point of the compass point, and you make it a line that's as thick as the saw blade, so that when you cut the two in half, you cut exactly down the middle of your thick pencil line so that the two halves are exactly equal. The evenness of the side bearings is more critical than anything else on the telescope, just about, because these surfaces all have to be absolutely identical. They'll eventually be covered in laminate, and the smoothness of that circle with the laminate on it, riding on the Teflon bearings inside the side of the cradle, determines how well the telescope moves and how smoothly it moves. So these have to be more or less exact semicircles. We therefore need to get them all into line. So in their rough state, first of all line them up on your bench and use your square to make sure that they're all standing vertically upright. Then take your clamp and clamp them together. And also clamp them on the other side as well. Then use a rasp, and if they're very rough you can use the block plane first to make this side nice and smooth. But concentrate on getting this side nice and smooth first. You know that it's square by virtue of the fact that they've been clamped into the square position. Clean them all up and make sure that this line is completely straight. Having done that, you then turn them over and, working one side at a time, you use your rasp to round off any unevenness between the various pieces. Before you start sanding the discs, you can see here I've put the four together, and you can see that these two are slightly smaller than those two. You can also see that there's a lot of roughness, and that bit has been cut in slightly, so it's got a raised high point. There's a little bit of a dip inside there, that bit standing slightly proud, and all of that has to be evened up so that the edge here and the edge there are square and they're all completely flat in relation to one another. And you need to keep rasping it and filing it down until all of these surfaces become equal. And here we have the finished product. As you can see, the sides and the faces are square, completely square, and they're all nice and even. And you can see as you go round the edge that they're all nice and smooth, and there are no low points, no high points. All the high points and low points have all been evened out, and that's now nice and smooth. You start off by rasping it away using the rough side of the rasp, and then once you finish doing the rough side of the rasp, you finish off using the fine side of the file in order to get rid of any last little vestiges of high points, and so that it feels nice and smooth. A tiny amount of roughness in the surface doesn't matter. That actually aids and assists when it comes to gluing the laminate on. But as long as you've got nice, smooth, gentle, even curve all the way around the edge with no high and low points, it's a nice, continuous, smooth curve. That's what you need to achieve. When it comes to doing the bearing keepers and the reinforcing fillets, draw the centre line, measure and mark the centre line, and then draw 6 millimeters either side using the very fine pencil. A self-propelling pencil like this is best. And when you cut it, use the coping saw, and remember to cut as close to the line as possible. Don't go to the outside. The object of the exercise is to get the two joints like that so that they fit snugly at 90 degrees, so keep the coping saw square and make sure that it's deep enough. If it slightly undercut it to start with, and if you find the two pieces don't slot together fully, like they don't here, you just need to trim that much away from one of the slots, or half of that amount from each of them, until they both fit. To find the centre of your hexagon is an easy matter of putting a straight edge from corner to corner, drawing a line, then the other two corners adjacent, line it up carefully, draw another line. You've already got the line going through the centre. And where the three lines join in the middle is the centre of your hexagon, and it's at that point that you drill your hole for your 10mm bolt to join the cradle base and the ground board together. Next we'll mark up the cradle sides, and you've got to have fixing holes for the bearing keeper and its reinforcing fillet, and the centre line of the notch from the bottom is 32 centimetres. So from the base there to the centre of that fillet is 32 centimetres. Draw your line. The bearing keeper is of course exactly central on the side, so you draw your line there. Then equally spaced drill holes, 5 for each. The next thing you have to consider is the front panel, and the front panel is going to sit between this piece and this piece. Now have the two outside faces facing towards you and choose which side you want to have for your front panel. Here I've chosen to have the front panel lined up with these two here. You have the fillet at the back on both sides, and for that you bring your pencil line in 6 millimeters from the edge, because it's a 12mm board that's going flush to the back there, and come in 15 millimeters from each edge of the fillet. You don't want to put the screw too close to the very edge of the fillet or you'll split it. You need to countersink the holes on the good side for the front panel here and the back panel here, but obviously where the bearing keeper and the reinforcing fillet go, these holes have to be countersunk on the inside of the cradle. In other words, on the other side, as this is the good face. Before attaching the bearing keeper to the side of the cradle, mark with a pencil line where the bottom of the hemisphere meets the bearing keeper. Make a little pencil mark, and then make a rebate in the bearing keeper of 3 millimeters all the way along to the pencil line. You could use the coping saw to do it, you could use the hand saw, whatever, but make a 3mm gap there. That will be enough for 2 layers of felt to be glued on there later, and that stops the bearings from moving in and out of the cradle. To fix the bearing keeper to the side of the cradle, get your 90-degree square and hold the cradle side so that it's flush with the bench, and carefully offer the bearing keeper up to the cradle and line up the centre of the hole with the centre of the bearing keeper. Just stick to just this top hole to start with. Once you're satisfied that it's square, you have to hold it very carefully and drill a small pilot hole into there and screw the first screw through into the bearing keeper so that it's nice and tight. Having done that, you can then turn this on its side and then carefully line up the centre of the bearing keeper's edge there with the screw holes so that the screw hole is absolutely dead centre to the keeper. As you screw your cradle together and put the front panel and back panels on, you want to make sure that it's square. Now, if it turns out to be square naturally, great, no problem. Check each side with your angle. Now, if you find that it's not square on all sides, what you can do is make up some squares that you know to be square. You can drill holes into them and then put them into the cradle base, having slackened off the screws holding the front and back panels, and screw them into place so that they hold the corners square. Next, we want to mount the cradle onto its base, and the way to do that is you take a pencil and you mark around. First of all, you centre the cradle on the base so that it's equal on all sides and at the corners. Have it so that the point is going towards the rear and the front, and that the two sides have got the flat sides presented to them. Having centred it, you get a pencil and you mark your way all the way round it so that you have an outline of the cradle box on top of the base. Then what you do is you take the cradle off the base, and where you have the outline, you drill 3mm pilot holes dead centre through between the two lines. Do that for all the pieces all the way around. Put your screws between 2 and 3 inches spaced apart, but I reckon on about sort of 5 screws per panel approximately, and a couple of screws for the 2 bearing keepers. Having drilled the pilot holes, put the cradle upside down on the worktop and put the base on top of it and line up the base with the cradle. Once you've done that, take one corner, make absolutely sure that that's lined up, and drill a pilot hole through the existing pilot hole in the base into the cradle. And then you drill that hole out 4mm for the screw to go through and countersink it and mount that screw into the cradle. Turn the cradle around 90 degrees and line up the other side so that these two sides here are perfectly in line. Visually check the back to make sure that there's no discrepancy between the cradle and the top vis-a-vis the lines. And when you're happy that it's lined up correctly, you do the pilot hole, drill, countersink and screw that corner. You then move on to the other 2 corners, and then you do all of the holes, you pilot drill all of the holes, then use a 4mm bit to open them all up, countersink them all and put your screws in. Now with the ground board, you need to make up 3 feet, just use an old offcut and cut some crude squares. It really doesn't matter what they look like or if they're a bit rough or whatever, for the simple reason that they're underneath the ground board and you're never going to see them. These are about 1 3/4 inches. I specified 2 in the literature, but anything between 1 and 2 inches is perfectly fine. And then what you have to do is you have to work out where the feet have to go. They're placed at thirds on the ground board, and essentially they're going to be directly below the Teflon bearings. If you look in the PDF, you'll see the drawing plan for the radii. You can use a piece of old wire like this to draw your line, and what you do is you take a tape measure or a ruler and you measure along to where, from the pivot point to where the radius is, and then very carefully holding the pencil and the wire together, you slowly go round, drawing out a circle all the way around, and that will be the circle for the feet to be mounted on. And then you draw a second circle a little bit further out at 450. It's got to have a radius of 225 millimeters because the disc is 450 millimeters in diameter for the laminate. The reason that these feet are obviously set in a bit is because the feet are going to be mounted directly underneath the laminate. So what will happen is that you'll screw through the board into the foot 2 screw holes, and where you've got those 2 screw holes, you'll cover them with your pad of laminate. So countersink them to make sure that the screws are well into the surface. I've drawn 2 rather crude circles, and essentially this circle should be inside of this one by just over 1 inch because of these squares. You coat a square with glue, and because the 2 holes are running in that direction, you want to line the foot up in that axis so that the 2 screws go into the centre on a long axis. It's then a simple matter. You put the screws into the holes, you have your screwdriver ready, you go underneath the board and have a look, line up the 2 screws on the pad, push the pad with the glue up against the board, hold it tight, and then start the first screw off gently until it bites into the pad. Repeat the same for the other 2 holes. We stick the large laminate bearing disc on using contact adhesive. It couldn't be easier. I've drawn the circle on the top of the cradle base that equates to where the laminate's going to fit eventually, and then you paint your contact adhesive all over the surface, completely covering it with a good thick layer, so that it just comes slightly over the line where the disc has to stick. You cover the disc, the back of the laminate disc, with the contact adhesive as well, and when the 2 have gone touch dry, you very carefully offer the disc up to the cradle base so that it's lined up, and then gently apply the laminate. Do be careful to make sure that it is correctly lined up before you actually put it down, because once these surfaces meet, it's really difficult to separate them again. The ground board has had its feet fixed onto the other side with the 2 screw holes through, and then you put a little dab of contact adhesive onto the board, and then you stick your Teflon bearings on. And this is what the bottom of the base of the cradle looks like with the stardust laminate put onto it. And that laminate essentially is just riding onto those bearings. So now we shall put the 2 together. You take your M10 nut and a large washer, you feed them to the bottom of the round board, and fit the bolt through the hole in the cradle, and then you put your washers on the inside of the cradle, and you use the special nylon lock nut. It's got a little section of nylon in there which helps to hold the nut in place. And that goes inside the cradle box. Then you hold on to the nut on the inside of the cradle using your adjustable spanner. So tighten the spanner onto the nut and hold it. And then you can either use another wrench, or if you have a 17mm spanner, you can use that to tighten up the bolt on the underside of the ground board. In terms of tightness, you have to find a compromise between the cradle sitting on the ground board tight but at the same time it must be able to turn freely. That means that the bolt isn't holding the two components under tension, and that way it allows your cradle to turn freely on top of the ground board without there being any sideways play or looseness in it. Now put the felt onto the bearing keeper recesses. Put some contact adhesive onto the inside face of the bearing keeper. Take your first strip of felt and stick it on so that it projects very slightly over the top there, and it also overlaps on both sides. You apply some contact adhesive to the first piece of felt and apply the second strip. So that it sits directly over the other piece and is projecting over all sides as before. After a couple of hours, when this is fully dry, you can use a knife and use it like a scissor against the bearing keeper just to trim off the excess felt. And now I'm going to offer the bearing up to its housing, just to make sure that everything fits properly and nicely, that it slides smoothly. That's great. Now you'll notice that between the bearing and the Teflon pad there's a gap, and you may also notice that the second of the two pieces of plywood is smaller than the piece with the laminate on. By filing the two semicircles together, you make sure that when the laminate goes on to the outer one, it actually stands slightly proud of the one on the inside. It's terribly important that this one on the inside is slightly smaller than the one on the outside, in case the outside one is pushed slightly past the cradle. And if the inside one is obviously overlapping, there's a danger that that inside one could then chafe on the side of the cradle. So do make sure that the inner semicircle is definitely the same size or smaller than the outer one. As with the felt, you apply the rubber blocks using the contact adhesive. So having painted the contact adhesive on thoroughly, you do the same to the feet. And I'm painting you notice that the rubber's slightly curved naturally. Well, I'm painting the inside of it. And once the contact adhesive is dry, you push the rubber on very firmly and keep pushing on it to make sure that it's stuck down properly. We're now ready to balance our telescope to make sure that the bearings are fitted into the correct position. The problem is, of course, you've finished your telescope body, but you haven't got the optics. And in order to balance the telescope properly, you really need the optics to be able to do it properly. But as it may be a while before you get your mirror, especially if you're planning on making your own, but in the meantime, of course, you'd like to have your telescope set up and functioning even without a mirror, we can still approximate. Now, if you make the mirror, getting the blanks from us, our design has picked up on a mirror blank that weighs about 3¼ kilograms. So I've weighed this and taken a load of substitute weights to work on the telescope. So if you muster together a group of heavy articles that equate to about 3.25 kilograms, I found I've got a box of nuts here, a thick, fairly heavy roll of gaffer tape, and a container of glue, which is almost full. And what you have to do is work out where your mirror is going to be. So measure in from the edge at the back of the telescope in towards the tube to where the centre line of the mirror would be. Put a little bit of tape on your telescope and draw a line that equates to the centre of where the mirror will eventually fall. It's a good idea to have your mirror cell fairly loose so that it's going into the telescope body a bit. That means that when you do eventually fit your mirror, when you adjust it and pull the springs back, if anything, the weight will come back this way just very slightly. Okay, so you put your heavy objects on top of the back of the telescope, centred on the centre line there. You have a broom handle and you clamp it to your worktop, broom handle being a nice round object for it to balance on. At the other end of the telescope, it's important that you have as many eyepieces in as you could possibly have for a viewing run. So in this particular instance, I've used a 2-inch 1.6 Barlow, and then I've put a second eyepiece into that just to make sure that I've got the weight at this end of the telescope. You must, of course, have the spider fitted inside the telescope and all the other components before you try balancing the tube. Because I haven't got an optical flat yet, I've just taken a small spanner which would approximate the weight of an optical flat, and I've placed that on the centre line of the focuser, because that's where the optical flat will be, of course. The next trick is you then pull the telescope tube backwards and forwards on the handle. Make sure that you've got it on at the same distance from the edge on the handle on both sides of the tube assembly, because obviously if you're balancing it, it's important that these distances here are equal, otherwise your bearings will be in the wrong place. And you gently rock the telescope and just hold it on the broom handle and see if it has a tendency to fall in either direction. If you find that it's more or less sitting proper, so that if you push it that way, it just drops and just touches, or if you pull it back the other way, then it rolls over and drops, that's more or less the balancing point. It'll hold there and it'll hold here. To be more precise though, again, check both sides because you might inadvertently twist the tube slightly. Now, having got to that position, you want to get to a position where it's practically balanced on the broom handle. And so you just gently tease it backwards and forwards until it's almost prepared to support itself by itself. Finding that exact point is quite difficult. You just have to keep fiddling around. When you've got to that point where it is balanced correctly, to make absolutely sure, measure in from the edge there to the broom on this side and on the other side, equalise them. When those measurements are both equal and you've got that balance, you know that that is the precise line of balance for the tube assembly. At that point, you draw a little mark at the exact top of the centre line of the broom handle there and on the other side. As long as you've got all these sides here straightened, you've taken off any excess timber so that these are all completely square, you could then use the right angle part of your saw like so. If you then offer that up to the tube, you can transfer those measurements around the tube. Remember to do this with a pencil that you can wipe off or rub off afterwards. Mark the lines from there to there, make sure that they correspond all the way around the tube. When you have that line all the way around the tube, that line equates to the very centre line of the actual bearings themselves. Having drawn the centre line of the bearings onto the tube assembly, put the tube assembly into the cradle and measure from the line for the centre bearing to the top of the two sides of the cradle here, which correspond to the centre line of the bearing. The difference between that and that is how high the tube assembly should be inside the cradle for the bearing to sit. So then, having taken that measurement, you take fillets of offcuts of various bits of plywood, 12mm, 9mm and 3mm, and pack up the base so that when you put the tube assembly in, the centre line will be sitting on the centre line of the cradle. You then take the optical tube assembly and fit it into the cradle to where it's going to be fitted. You then check to make sure that the gap between the tube and the cradle is parallel on both sides. You go to the front and check to make sure that you have a very small gap between the front panel of the cradle and the tube assembly. And what you do is you move the telescope along until the centre line there corresponds to the centre line of the keeper there. So then you know that the tube is centre from front to back in the cradle. And also work it from side to side to make sure that those two distances there are equal as well. So after careful positioning, it's a simple matter of taking your bearings. I've arranged the holes on the bearings so that you have 3 holes 20mm in from the edge of the circle and 1 down from the top. I've drawn a line of 15mm from the top down. 3 at the top, 1 in the centre at the bottom. That's sufficient to hold the bearing onto the tube assembly. Slot the bearing carefully into its keeper. And because of the distance of the pads, the Teflon pads, apart from the centre, if you carefully move your keeper around until the top edge of the keeper there is just touching the front edge there, that gives a nice appearance from an aesthetic point of view. But the other point is that the bearing here is not going beyond the Teflon pad there. And also when the telescope is turned to its full 90-degree down position, that corner there won't go past that Teflon pad there. If you had the bearing positioned like that, as you go down, the edge there will miss the Teflon pad and it will come off. This is why you have to set it at somewhere between 30 and 45 degrees. Once you've put the 2 bearings into position on both sides, double check all your measurements, the twist back and forth, the distance from the front edge to the front panel, and when you're satisfied that everything's in the correct position, carefully, without moving the telescope, tube assembly or the bearing, carefully drill a 1mm pilot hole into each hole and then screw your screws in. Having lined the bearings up to the tube assembly and screwed them into position, if you allow your telescope to rock backwards and forwards, check the bearings inside their keepers and make sure that everything's correctly aligned and that you have a nice smooth even movement on the telescope from top to bottom, from horizontal to vertical. One additional problem that I overlooked on the original design is that when the telescope goes to the vertical position, the nut in the bottom of the cradle sticks up very slightly, and so as the optical tube assembly was moving down into the cradle, the edge of it here was catching on the nut. If you just put a couple of pencil marks where the nut of the cradle interferes with the edge of the bottom of the optical tube assembly, and just cut a little notch away to allow the bolt to pass through, that's sufficient to overcome that problem. And that's the completed telescope, and the only thing that you need to do now is make a decision about how you're going to paint or varnish it. The possibilities are endless, and I leave it down to you to make your own decisions on that.